The United States has issued a fascinating challenge to NASA, to establish a unified standard of time for the Moon. At first glance, this may seem like a straightforward task. After all, why not just use Earth time on the Moon? However, the complexities of timekeeping in space go far beyond what we experience on Earth. Time on the Moon, in fact, behaves quite differently from time here on our home planet. The question then arises, why isn't lunar time just the same as Earth time? Isn't time universal? In our everyday lives, time feels like a constant force, ticking away steadily, providing a rhythm to our activities. We glance at clocks and know exactly what time it is, at least, that's what we assume. But the reality of time is far more complicated, and it becomes even more intricate when we venture beyond the confines of Earth. This is because, as Albert Einstein's theory of general relativity tells us, time is not an unchanging, absolute force. Instead, time is shaped by gravity, which means that it moves differently depending on where you are in the universe. One of the most mind-boggling aspects of our universe is that time, although it may seem constant, can stretch and compress based on several factors, including gravity and motion. A clear example of this concept is that time passes slightly faster at the peak of a mountain compared to the valleys below. While this may sound insignificant when considered on Earth, it takes on much greater importance as humanity stretches its reach into outer space. This becomes especially true when we consider lunar exploration. The new space race, fueled by ambitions from countries like the United States, China, and others, is igniting the next frontier of space exploration, with one of the most important goals being the establishment of permanent settlements on the Moon. As humanity looks to return to the Moon, the issue of timekeeping has suddenly taken on a critical role. This brings us to a perplexing challenge: how do we keep time on the Moon when seconds tick just slightly faster there than on Earth? Before we dive into the intricacies of lunar timekeeping, it's helpful to take a step back and look at how we measure time here on Earth. For millennia, human beings used natural systems like sundials and the phases of the Moon to track the passage of time. These methods worked well for early civilizations, but as technology advanced, the need for more precise timekeeping became clear. By the 14th century, mechanical clocks began to emerge, and soon after, more advanced timekeeping devices revolutionized the way we measured time. By the 20th century, timekeeping had evolved into an exact science, especially after Einstein introduced his groundbreaking theory of relativity. Einstein proposed that gravity has a profound effect on the flow of time. Essentially, the closer a clock is to a massive object, like Earth, the slower time flows for it, compared to a clock that is farther away. This means that clocks on Earth tick at a different rate than those in space, a realization that is particularly important as we venture into outer space. Today, atomic clocks have become the gold standard for measuring time. These highly precise devices rely on the vibrations of atoms to track time with incredible accuracy. Atomic clocks are now used around the world to produce Coordinated Universal Time, (UTC), the global standard for timekeeping. This system is essential for everything from navigation and communication to financial transactions. But this reliance on precision time measurement also introduces a new challenge: even the tiniest variation in the passage of time must be accounted for. To keep UTC synchronized with Earth's irregular rotation, leap seconds are occasionally added. As we prepare for lunar missions, the need for precision timekeeping becomes even more pressing. Unlike Earth, where time is measured according to the planet's rotation and gravitational forces, the Moon's unique characteristics present new challenges. For example, one of the most significant differences is that a single Earth day lasts 24 hours, but on the lunar surface, a single day is about 56 microseconds shorter. While this might seem like an almost negligible difference, it can add up over time, leading to significant inaccuracies that could affect long-term operations, including navigation, communication, and scientific experiments. To ensure that astronauts on the Moon can stay on schedule, coordinate activities effectively, and perform essential tasks, it's crucial to account for these subtle differences in time. NASA, in collaboration with international space agencies like the European Space Agency, ESA, is working diligently to solve this complex problem. The goal is not just to create a lunar time zone, it's far more complicated than that. Instead, the task is to develop a completely new time scale, one that takes into account the Moon's distinct characteristics and allows for precise synchronization of lunar activities. Cheryl Gramling, a leading expert in lunar navigation and timekeeping at NASA's Goddard Space Flight Center, explains that the aim is not merely to create a lunar time zone. Rather, the goal is to devise a time system that accurately reflects the faster ticking of seconds on the Moon. Gramling's team is collaborating with international partners to develop a system that can be universally adopted by space agencies. A recent directive from the White House has called on NASA to outline a plan for this new time scale by December 31, 2025, with full implementation expected by 2026, the same year the United States plans to return astronauts to the Moon for the first time in 5 decades. Creating an accurate lunar time system is vital for the smooth operation of lunar missions. This will guide everything from astronaut navigation on the surface to real-time communication with mission control on Earth. But in order to make this work, highly precise clocks must be deployed to the lunar surface. The Moon's environment, however, presents unique challenges that will require new strategies. While atomic clocks are ideal for long-term stability, they are expensive and may not be practical for all lunar missions. As a result, scientists are exploring alternatives, such as crystal oscillators. These devices offer good short-term stability at a lower cost, but they come with trade-offs. Crystal oscillators, while more affordable, can drift by milliseconds or more over time, something that could spell disaster for navigation systems relying on pinpoint accuracy. To achieve the necessary precision, scientists are planning to deploy a variety of clocks to the lunar surface, possibly embedded in satellites orbiting the Moon or placed at key locations on the lunar surface itself. By using a network of different clocks, scientists hope to develop a timekeeping system that can support the complex needs of lunar missions. This network would need to synchronize with clocks on Earth as well as those on spacecraft in lunar orbit, creating a unified system for time on the Moon. The challenge of establishing a new time system for the Moon is not only technical but also diplomatic. Space exploration is increasingly becoming an international effort, and the success of any lunar mission will require cooperation between various space agencies. This is where LunarNet, a global communications, navigation, and timekeeping network for the Moon, comes into play. Think of LunarNet as an advanced version of the Internet, combined with a global satellite navigation system. It will serve as the backbone for lunar operations, ensuring that activities on the Moon are coordinated in real time. LunarNet's success depends on international cooperation, as various nations will need to agree on a shared set of standards. This is particularly crucial as NASA and its partners work to establish this network, which will be used by astronauts, scientists, and robotic systems working on the lunar surface. However, there may be challenges in getting space agencies like China, which is not part of the Western Space Alliance, to join this global initiative. These discussions will likely unfold in international forums like the International Astronomical Union, IAU, and it will be crucial for NASA and its partners to navigate these diplomatic challenges. Timekeeping on the Moon has broader implications beyond just lunar missions. The Moon's unique orbital mechanics mean that one lunar day is equivalent to about 29.5 Earth days, with 14 continuous days of daylight followed by 14 days of darkness. This extended cycle presents a whole new set of challenges for astronauts, as their daily routines will be disrupted by the long periods of light and dark. Timekeeping will be essential for coordinating activities, from scientific experiments to surface exploration. However, Gramling sees the Moon's day-night cycle as an opportunity to rethink how we experience time. With 14-day stretches of sunlight and darkness, astronauts will have the chance to create entirely new routines, schedules that are tailored to the Moon's environment. These schedules may be unlike anything experienced on Earth, but they will be structured around a precise and reliable timekeeping system that ensures mission success. While the challenges of lunar timekeeping are substantial in the short term, they hold significant long-term implications for the future of space exploration. If we can create a reliable time system for the Moon, this technology could be adapted for missions to other celestial bodies, such as Mars or asteroids. For example, NASA's long-term goal of sending humans to Mars will require a system that accounts for the unique length of a Martian day. The work done for lunar timekeeping will be invaluable for these future endeavors, laying the groundwork for missions far beyond the Moon. The quest for accurate timekeeping on the Moon is not just a scientific challenge, it's an opportunity to expand humanity's understanding of time itself. As we prepare to return to the Moon and venture further into the cosmos, developing a precise lunar time scale is foundational to the success of future space missions. By collaborating internationally and building on Earth-based timekeeping systems, NASA and its partners are paving the way for a new era of space exploration. This journey not only marks an important milestone in humanity's exploration of our nearest neighbor in space but also sets the stage for more ambitious missions to explore the stars. In a universe shaped by the laws of relativity, mastering the